Namaste. Myself Jivin Gorakhpur from the discipline of meteorology in the diagnosis. I am in the Department of Diagnostic and Community Health from the Faculty of Physiotherapy and Diagnostics, Vidyapeeth, Women's University. Today we are going to discuss a session that is very useful for or to understand the general radiation physics setting or the physics behind the X-ray production in the X-ray tube or the surrounding and about the radiographic techniques of whole world. In today's session, we will discuss about the particle interaction. Because when photon interacts or any radiation interacts with the atom, so there are various processes that occur after the interaction. For particle interaction, in this type of interaction, charged particles lose energy in a medium by ionizing and exciting the atom of the medium. Okay. So, in the charged particles lose energy in the medium by ionizing and excitation of the atom of a medium. Okay. In this process, energy also released and energy is released in the form of ionizing atom of medium. Excitation and ionization occur when charged particles lose energy by interacting with orbital electron. Means when charged particles interact with the orbital electron, any orbital electron like K orbital electron, L orbital electron, M or N orbital electron, then excitation and ionization occur, and in this process the charged particle loses energy. As a result of ionization, ion pairs are produced. The energy required to produce an ion pair in air is 33.7 electron volt. Okay, so as a result of ionization, ion pairs are produced. So the required energy for ion pair production is equal to the 33.7 electron volt. Sometimes the ejected electrons produce further ionization. This is called secondary ionization. These electrons are called delta rays. Thus, the ionization and excitation occur along the path of a charged particle in a medium, and the rate at which the ionization and excitation occur along the path of a charged particle in a medium, and the rate at which the ion pairs are formed depend upon the charge and energy of the incident particle. Okay. So rate depends on the charge and the energy of the incident particle and the atomic number of a medium. The number of primary and secondary ion pairs produced per unit path length. The number of primary and secondary ion pairs produced per unit path length of a charged particle is called specific ionization. Okay. As the particle charge increases, its velocity decreases. Thus, the specific ionization of alpha particle is higher than that of proton. Charge increase means the alpha particle is having more charge than the proton, so the velocity of the alpha particle is less than the proton, so the specific ionization of alpha particle is higher than that of proton, because its velocity is lesser than it interacts more than atom or particles in the medium. Okay, so the specific ionization of alpha particle is higher than the proton. Namaste. In today's session, uh, we will discuss about the space charge effect. That is very important when we are studying about the X-ray. So the space charge effect uh, limit limit the KBP setting above 40 kV. Okay. To understand the operation of X-ray tube, it is essential to know how the tube current depends on the tube voltage for a given filament excitation. Okay, when we study when we are studying the operation of a tube, it is essential to know how the tube current depends upon the tube voltage for a given filament excitation. Okay, so the effect of the tube current over tube voltage over the tube current. Okay, when a few kVp is applied across the tube, the electrons are surrounding the filament. When a few kVp is applied across the tube, the electrons are surrounding the filament and form a cloud. These electrons tend to repel electrons back into the filament. These electrons that is surrounding the filament, uh, these electrons having a tendency to repel electrons back into the filament, and hence the current is very small. The cloud of electrons is known as space charge. Cloud of electrons surrounding a filament is called or known as the space charge. As the KVP is increased, the effect of space charge are overcome. As the KVP is increased, the effect of space charge are overcome gradually, and current also increased in the X-ray tube. In the space charge region, the tube current is strongly dependent on the tube voltage. Okay, for a constant filament current. Okay, in the space charge region, the current dependent on the tube voltage for a constant filament current above 40 kV. The electrons in cloud surrounding the filament are pulled towards the anode. This is called the saturation or emission limited region. Okay, so the below the 40 kV there is a region or cloud that surrounding the filament that repels the electrons back to the filament. That is called the space charge effect, space charge region. Above the 40 kV, the electron in the cloud in space charge region surrounding the filament are pulled towards the anode, pulled towards the anode. Okay, this is called saturation or emission limited region. In this region, the tube current undergoes little changes with an increase in tube voltage. Tube current undergoes little changes with an increase in the tube voltage. Thus, the filament current controls the tube current in the situation. In this situation, the filament current controls the tube current. Okay. Most of the X-ray tubes are operating between the space charge region, means cloud region, and the saturation region. Thus, the tube current is determined by both KVP and filament current. This curve, space charge effect, the curve between the tube current and the applied voltage depends on many factors, include the distance between the anode cathode, the configuration of the focusing cup, the focal spot size, and the filament temperature. Particularly, the change of the potential of focusing cup will drastically alter the curve between the tube current and the applied voltage. Okay, thank you. So today's session we will discuss about the coherent scattering, that is particularly important for the course General Rate Scientific second in the BScRT second semester. Okay, so let me start about the coherent scattering. Okay, what is coherent scattering? In this process, low energy photon interact with the electron. Low energy photon interacts with the electron of an atom and set them into vibration at the frequency of radiation. Okay, set them means it converts the electron into the vibration of the at the frequency of radiation. A vibrating electron, since it is a charged particle, emits radiation in different directions. Okay, thus in coherent scattering, the photons undergoes a change in direction without change in wavelength. Okay, so in coherent scattering, the photon undergoes a change, means it changes its direction without changing wavelength. Okay, in this process, no energy is transferred and no ionization occurs. Okay, in this process, no energy is transferred and no ionization occurs. Coherent scattering contributes less than 5% in diagnostic radiology. So it contributes in the diagnostic radiology, but in a less amount, less number. So it gives a vibration to the electrons uh, these electrons interact with the photon, coming photon. Okay. So in this process, the direction changes and the wavelength is remain same. Okay. Thank you. The session is over. This session is powered by Digital Version 2.0, JOP Vidyapeeth Women's University, Jaipur. I think you will satisfied with the session. If you have any queries,